Dear students, today we are going to study the higher secondary physics practical second year. Okay, so you all know that we have 12 experiments in the second year, right? So first of all we are going to study potentiometer. Okay, so the aim of this potentiometer is the comparison of EMF between two cells. So the components used in this potentiometer are battery, Riostat, DTDT switch, electrolyzer, Danexer, Galvanometer, high resistance and job. Okay, so here I have numbered these components. Okay, so in this apparatus we can see all these numbers. Right.
Observe the construction of the potentiometer. The potentiometer is an instrument used for the measurement of potential difference. It consists of a 10-meter long uniform wire of manganese or constantan stretched in 10 segments, each of 1 meter.
Friends, this is the potentiometer apparatus. See here, potentiometer is right here, right? In this apparatus, a 10-meter length wire is placed here or fixed here. Okay. So the ends of this wire is marked as A and B. Okay. And this wire is made of manganese. That is in our lab, manganese wire is used. And this 10-meter wire is arranged as 10 segments, one having 1 meter length each. See, there are 10 segments are there. First line is this, second line, third, fourth, fifth, sixth, seventh, eighth, ninth, 10. So 10 lines are here, each having 1 meter length. And again a meter scale is connected in this potentiometer device. See here, and in this scale, upper side and lower side are marked. Centimeters are measured, right? So look here, this upper scale is measured from 0 to 100. That is from left to right, 0 to 100 is marked. Look at the lower side. Here it is marked from 100, 99, 98, 97, 96, etc. up to 0. That is, the lower scale is measured from right to left. That is, 0 started from right and 100 ended up to left. Got it? So this is the potentiometer apparatus. And the end of these terminals are marked as A and B. Okay, you get it? Then the other components used in this apparatus is, first one is battery. Look here, this is the battery. And in this battery, two terminals are there. Look here, this is marked as terminal 1, right? And it is red in color. So this is the positive terminal of the battery. And this is marked as 2. And this is seen as black. So this black terminal is the negative terminal. Okay. And here I made this battery in 4 volts. So this battery is having a potential difference of 4 volt. Got it? Then the second device is a key. This is a key. This is having 2 terminals, right? So the first terminal is marked as 4 and the second terminal, the first terminal is marked as 3 and the second terminal is marked as 4. And this is the key we represented. Okay. Now if I take this outside, then it is an open key. If I place it inside, then only it will be closed. Okay, right. Then next, the third component, it is the rheostat. This is a rheostat. Look here, look closely. There are a many number of wires are wounded here, right? This is wounded over a cylinder. Okay, and this is a conductor. Look at this device, this is a conductor, right? When I moved this conductor, the number of turns included in this device is this much only. Okay, and this number is a huge number because it is tightly closed, right? So whatever current flowing through this wires, okay, this much number of wires will be the current that in this device, that is that give by this device. Okay, so if we connect this rheostat to an ammeter, we can measure the current, but from this rheostat we cannot able to measure the current. Okay, so in this potentiometer device there is no ammeter, so we cannot able to measure the current from the rheostat. Okay, got it? And in this rheostat there are two terminals. Okay, so next terminal is fifth one that I have marked here, right? This is the fifth terminal that is on the lower side, and the diagonally opposite side, on the upper side, there is another terminal which is marked as 6. Okay, which is marked as 6. So this is the third component, rheostat. Got it? Then the fourth component, that is the DP-DT switch. This is the DP-DT switch. The full form of DP-DT switch is double pole double throw switch. So that is, we call it as short as DP-DT switch. And in this DP-DT switch there are 6 terminals. The first 2 terminals I marked it as 7 and 8. The another 2 terminals are 9 and 10. And the other 2 terminals are 11 and 12. Okay. So this is the fourth component. Okay. Next, the fifth component is Leclanche cell. Okay. So here there is a small difference between Leclanche cell and battery, because in this Leclanche cell the potential difference is 1.45 volt only, right? But in this battery we can use potential difference, or we can make the potential difference in different levels. That is, we can make it as 2, we can make it as 4, we can make it as 6, 8, etc. Okay, so now I am connecting this potential difference by 4. Okay, because here 4 volt is used for this potentiometer device. Then coming to the Leclanche cell, its potential difference is 1.45 volt. Okay, and here I marked the positive terminal, that is showing red, right? This positive terminal is marked as 13, right? And the negative terminal is marked as 14. Okay. Then the sixth component is Daniell cell. This is the Daniell cell. Okay. The potential difference of Daniell cell is 1.08 volt. Okay. It is 1.08 volt. And the positive terminal is marked as 15 and the negative terminal is marked as 16. Right. Then the seventh component, that is the galvanometer. This is the galvanometer. Okay. And you can measure reading from the galvanometer. Okay. So look here inside the galvanometer. This is the central part 0. On the right side you can measure 10, 20, 30, etc. On the left side also you can measure 10, 20, 30, etc. Right. That is, the central part is always 0, and towards the right side and the left side you can make measurements in galvanometer. And this galvanometer device is used to detect the presence of current inside the circuit. We cannot able to measure the current, but we can detect the presence of current inside the circuit using galvanometer. Okay, see the positive terminal, or the terminal showing red is marked as 17, and this terminal showing black is marked as 18. Okay, this is the seventh component. Then the eighth component, next one, this is the high resistance. Look here, this is the high resistance. Okay, In this high resistance also there is a key. Okay, if I remove this key from the high resistance, then it is an open circuit. When I close only, then it is a 10k ohm high resistance. Okay, so this is the high resistance device, and it is also having two terminals. The first terminal is marked as 90 and the second terminal is marked as 20. Okay, and the ninth component we used here is the jockey. Look here, this is a jockey, right? This part is a conductor and this part is a conductor. In between that, a plastic is used which is a non-conductor, but inside this plastic a conductor is here. So this is a conductor. Okay, look at the tip, this is a conductor. When I placed this jockey in this wire, then only the circuit will be closed and the current flows through the circuit. Otherwise it will be an open circuit. And this terminal I marked it as 21. Right? You can see the connections. Okay. Here I marked the terminals as A and B. That is the end of the potentiometer wire is marked as A and B. From the point A, I connected it to the terminal 1 in battery. Right, that is the positive terminal. And from 2, that is from the negative terminal, I connected it to the key, that is towards 3. From 2 to 3. Then from 4, that is another terminal of key. From 4, I connected it to 5. This is 5. Okay. This is fifth terminal. So from 4 I connected it to the fifth terminal, that is the lower part of rheostat. Okay. And the sixth terminal is on the upper side of the rheostat. From 6 I connected it to B. So in between the terminals A and B there is a battery, a key and a rheostat. And these three components form the primary circuit of this potentiometer. Got it? Then again from the point A, I am connecting it to the DP-DT switch, that is to the 11th point, 11th terminal. Okay. And from the 12th terminal, I connected it to the galvanometer. Okay, to the galvanometer. That is, I marked it as 7. From 12 to 17. Okay. And from 18, that is another terminal of galvanometer, from 18 to 19, high resistance. And from 20 to 21, that is jockey. Okay, then look here, in this DP-DT switch, there is another 4 terminals. Look here, towards the 11th point, I connected it from A. And from 12, I connected it to galvanometer. Then there are other terminals also, 7, 8 and 9, 10. This 7 and 8, I connected it to the Leclanche cell. Okay, this point is connected, that is the left side, 7th point is connected to the positive terminal, that is towards 13. Right, I connected it to 13. From 8, I connected it to 14, that is towards the negative terminal. Okay. And from 9 and 10, I connected it towards the Daniel cell. From 9, I connected it to 15 and from 10, I connected it to 16. Okay, these are the connections. So look at this DP-DT switch. This terminal, that is from A, I connected it to the terminal 11 and from 12, I connected it to the galvanometer. So in this terminal, in between these terminals 11 and 12, a handle is placed here, and this is made of a conductor, that is current is passed through this handle, right? So when I placed this handle towards the terminal 7 and 8 or towards the terminal 9 and 10, then the circuit will be closed. Then only the circuit will be closed, otherwise the circuit will be kept open. Got it? So the connections are made. Now we have to go to the working of this one. And this is the tablet column we used. Okay. In this tablet column, the first column is serial number. This is the balancing net for electrolyzer. Okay. So here we are measuring the length. That is one of the balancing net for electrolyzer. now we are going to take readings. Okay, for that I have to switch on the battery, the Lagrange cell and the Daniell cell. See, in all these three, red light is glowing. So these are switched on. Okay, after that I have to make the hand of DTDT switch towards the gap of Lagrange cell. See, I fixed in this gap. That means Lagrange cell is in this circuit and the Daniell cell is not included in the circuit. That means the circuit is closed with the Lagrange cell only. Now I am going to take the balancing length. For that I take this jockey. Okay. Then I press the tip of the jockey towards the wires of potentiometer. Any of the wire. And you can see the galvanometer reading. See. It deflected. Right. And the next thing we have to check is if the connections are correct or not. I have already told you that, right? For checking the connection, I have to place the jockey towards the point A. So here I am placing the jockey towards the point A. Okay, then look at the galvanometer. It is deflecting towards the left, right? It is deflecting towards the left. Now I place this jockey at the point B. Okay, see? I place this jockey at the point B, right? Now look at the galvanometer. It is deflecting towards the right. Okay, that is opposite side deflection. While I am placing the jockey at the point A and B, the galvanometer is deflecting opposite sides. That means the connections are correct. I confirm that the connections are correct. Then for taking the readings, I have to move this jockey from the point A. Okay, so here I am moving from the point A. Now you have to look at the galvanometer. See, while I am moving from the point A, the galvanometer is not deflecting. So for easy of taking the readings, I placed this jockey at the second line. Then also the galvanometer is not deflecting. I placed the jockey on the third line. Then also it is not deflecting. Then I placed the jockey on fourth line. It is also not deflecting. Then I placed it on the fifth line. It is not deflecting. On the sixth line. See, on the sixth line it is deflecting. That means the readings we get only on the sixth line. Okay. So I have to move this jockey on the sixth line. For that, I started moving this jockey from this side, from the right side. Okay. Because the fifth line ends here and the sixth line starts here. So that is why I place the jockey on the starting line of sixth line. Starting point of sixth line. Then I began to move on the sixth line. Now look at the galvanometer. The galvanometer needle is vibrating now and it begins to move now, right? And at this point I get zero deflection. Look at the galvanometer. Now the galvanometer shows zero deflection, right? So I am placing the jockey on the sixth line at this point. Okay. At this point only I get zero deflection on the galvanometer. Now I have to measure the length of this potentiometer wire. For that I have to start from the point A. So from point A, 1, 2, 3, 4, 5. 5 lines are completed. The reading I have taken only on the sixth line. 5 lines completed means 5 into 100, 500 centimeters are completed. Because this is a centimeter scale. scale, 100 centimeters forms 1 meter, right? So here 5 meters complete, that means 500 centimeters are complete, and this is the 6th line. And another thing I have to told to you is that look at the meter scale. Here the 0 starts only on the upper side. So here A also starts from the left side, right? 0 starts from the left side of upper side of scale. So you have to measure the first line on upper scale only. Then again, once the first line completed on the meter scale, 100 reaches here. Then I have to measure the second line. Second line continues from this point, right? So in this point 0 starts on the lower scale, right? 0, 1, 2, 3, it is on the lower scale. So second line you have to measure on the lower scale only. So for simplicity, you have to know that the odd number lines you have to measure on the upper scale, and even number lines you have to measure on the lower scale. See here, the odd number lines, first one, third one, fifth one, seventh one, ninth one. These lines you have to measure on the upper scale, and second line, fourth line, sixth line, 8th line, 10th line. These lines you have to measure on the lower scale. Now we have to take the measurement on the 6th line. So I have already told you that 5 lines are completed, that is 500 centimeters are completed, and this is on the 6th line. 6 is an even number. So even numbers we have to measure on the lower scale. So for that I have to place this scale. Okay, this scale, and in the lower scale it measures as 68.5. See, it is on 68.5. So 500 plus 68.5 means 568.5. Okay, and we have to note this value. So look here on the tabular column, 568.5. This I measured it in centimeter, and I wrote it below the balancing length for rectangle cell F1. Right. Then the next thing we have to measure is the balancing length for Daniel cell for the same rheostat reading. Here the rheostat is placed here. We cannot able to measure the current from it. So by keeping the same position, we have to move the DPDT switch towards the 9 and 10 terminals, that is this gap. Now the Leclanche cell is free. Now the circuit is completed only with Daniel cell. Okay. Again I have to measure the balancing length for Daniel cell. Now we are going to measure the balancing length L2 for the Daniel cell. To measure L2, I have to place the jockey on the first line of potentiometer. See, the galvanometer is not deflecting. Then I placed it on the second line. Then also galvanometer is not deflecting. Then again on the third line, galvanometer shows no deflection. Again I place it on the fourth line. Then again galvanometer shows no deflection. Then again I placed it on the fifth line. See, in fifth line it deflected in opposite direction. That means in fourth or fifth line we get the deflection, or we can make the galvanometer needle to 0. So I began to measure from fourth line. Okay. So now I place this jockey on the fourth line, and the galvanometer is not deflecting, and then I began to move on the fourth line. Okay, see, the galvanometer needle begins to move. So in the fourth line itself, I get the 0 deflection. Okay, so at this point I get the 0 deflection. So at this point I get the zero deflection. Okay. Now look here on the jockey. Look here 3 lines are completed, right? So 300 centimeters are completed and I got the zero deflection on the 4th line. 4 is an even number and we have to take the 4th line reading on the lower scale. For that I place this scale over here. So look at the point here. The lower scale reading shows 85.7. So 300 centimeters are already completed. 300 plus 85.7 means 385.7. 385.7. So I write it below the balancing length for Daniel cell, that is L2. Okay. Now I have to repeat the experiment for different currents. For varying the current, I have to move the rheostat. Okay. So look at the rheostat. Now I move this. Okay. Now I am moving. So the current varies and for this current I have to measure the balancing length for Leclanche cell and Daniel cell. Okay. So now the circuit is closed with the Daniel cell. For that I am going to measure the balancing length for Daniel cell. So again I am placing the jockey on the first line, not deflecting, second line not deflecting, third line not deflecting, fourth line it deflects. Right. So I am moving on the 4th line. So at this point I get zero deflection. Okay. Look at this point jockey. At this point only I get zero deflection on the galvanometer. So here also 3 lines are completed and the reading I get on the 4th line. 4 is an even number, so we have to measure on the lower scale. So 300 plus, this is 71.9. So 300 plus 71.9 means 371.9. So it is 371.9. Now I have to move this DP/DT switch, the handle of DP/DT switch towards the 7 and 8 terminal, that is the Leclanche cell for the same current. Okay. So now I have to find the value for balancing length for Leclanche cell. Again I place the jockey on the first line, not moving, second line not moving, third line not moving, fourth line not moving, left hand. Fifth line not moving, sixth line moves. That is on the fifth line itself we get the reading. Okay. No, we didn't get on the fifth line. Again I went to the sixth line. So in sixth line I get the reading. So at this point I get zero deflection. Okay. See, the galvanometer shows zero deflection. So at this point I have to measure the zero deflection. Then look at the jockey. So look here, 1, 2, 3, 4, 5. 5 lines are completed. So 500 centimeters are completed. 6 is an even number. We have to measure it on the lower scale. So pointing towards the lower scale, the reading shows 8. So 508 centimeter. Okay, 500 plus 8, 508. So this is 508 centimeter. Okay, in this way, you have to repeat the experiment for varying currents. For 3 more values, 3 more varying currents, you have to measure the balancing length for Lagrange cell and dynamic cell. That is L1 and L2. Okay. So these are the balancing lengths for Lagrange cell and dynamic cell for various currents. So I have taken this. Okay. Then you have to find out the value of psi1 by psi2. Psi1 is the EMF of Lagrange cell. See, here it is noted that the EMF of Lagrange cell is 1.45. And what is the EMF? Do you know what is EMF? It is the potential difference of the Lagrange cell in an open circuit. Then what is potential difference? You all know that it is the work done to bring a unit positive charge from one positive terminal to the other negative terminal. Okay, this is the potential difference. So EMF is nothing but the potential difference in an open circuit. Okay. So this is the EMF of Lagrange cell and this is the EMF of dynamic cell. So by dividing this, we can easily compare the EMF of Lagrange cell and dynamic cell. And the equation for this is L1 by L2. Here you are measuring the values of L1 and here you are measuring the values of L2. So L1 by L2 is psi1 by psi2. That you have to calculate and write here. And finally you have to find out the value for mean psi1 by psi2. So that you have to write here. For that you have to add the 5 values and divide it by 5. Then you get the value of mean psi1 by psi2. In this way you can able to compare the value of EMF of Lagrange cell and dynamic cell.